GK Jain Schools, a great way to start your child's early education.
Subscribe now and press the bell icon. Never miss an update.
Good evening children, this is Padma from GK Jain Schools. Let us continue with Integral Calculus 2 from 12th Business Maths. In today's topic, we are going to see about the applications of integration in economics and commerce.
Let's see the concepts involved in application of integration in economics and commerce. First thing, let us see what are all the things we are going to study here. In this concept we will be studying about the total cost function, total revenue function, and we have something called consumer surplus and producer surplus, which we will find out from the demand and supply function. Then cost and revenue function can also be calculated to the indefinite integrals. Then cost functions from marginal cost function. That is, they will give you the marginal cost function from which we have to find out the cost function. That formula is C is equal to integral MC. MC is nothing but marginal cost into dx plus k, where k is the integration constant. Already there is a C, so only we are using k. And average cost function AC is equal to C by x, where x is not equal to 0. And we have something called rate of growth or sale. For this we use this formula, total sale is equal to integral 0 to t f of t dt, where 0 t lies between 0 and r. Let's see the sums now. So we will see the example sums first. Example 3.9. The marginal cost function of manufacturing X shoes is 6 plus 10x minus 6x square. The cost production of a pair of shoes is rupees 12. Find the total and average cost function. Okay. So the cost of manufacturing X shoes. So they have produced some X shoes. The manufacturing expression is given to be 6 plus 10x minus 6x square. Production of making a pair of one pair of shoes is rupees 12. So find the total average cost function. So marginal cost function MC is equal to 6 plus 10x minus 6x square, and the cost function is equal to integral of MC dx plus k. Okay, that is, we are going to integrate the marginal cost function. So what is the marginal cost function here? It is 6 plus 10x minus 6x square dx plus k. Okay. Now that is actually the integrating constant. Already we are having the C variable here, C alphabet here, so we are using a different variable here. So C is equal to, when I am going to integrate 6, I will get it to be 6x, 10x square by 2, 6x cube by 3. Okay. Now they have given for producing or for the production of a pair of shoes, that is 2 shoes, x takes the value, that is 2. Okay, x is here taking the value 2, the cost becomes 12. So we are going to substitute wherever x is there as 2 and C as 12. So when I am substituting, I am getting like this. So obviously this 2 and 1 2 will get cancelled, and this 3 and 2 will 6 will get cancelled to be 2, and 6 2s are, it will become 12. Here also there is a 12. So obviously this 12 and this 12 will get cancelled. So we will get the value of k to be minus 4. Now I will substitute the k value in the expression. C is equal to 6x plus 5x square minus 2x cube minus 4, and average cost is equal to C by x. So I am going to divide the whole expression by x. So I am getting it to be 6 plus 5x minus 2x square minus 4 by x. Now we will see the next example. The marginal cost function MC is 2 plus 5 e power x. Find C. If C of 0 is equal to 100, find AC, that is average cost. So the MC is given to be 2 plus 5 e power x. I told you this whole exercise is going to deal with the problems that are applications of integration in economics and commerce. So only we are having this cost function, revenue cost function, all these things will be seen here. So C is equal to MC, that is marginal cost function. This function we have to integrate this now. When I am integrating this, I will get it to be 2x plus 5 e power x, and they have given x takes the value 0 and C takes the value 100. C of 0 is equal to 100 means that is the meaning. So I am going to substitute wherever x is there as 0 and C value as 100. So now 2 into 0 becomes 0, e power 0 is 1, so 100 is equal to 5 plus k, so k takes the value 95. So I will substitute 95 back here in the expression, C's expression, and average cost is equal to C by x. So now I will divide, and I am getting the answer to be 2 plus 5 e power x divided by x plus 95 by x. Now example 3.13, a company produces 50,000 units per week. These sums, no, they will be asking in 3 marks. with 200 workers. So it produces 50,000 units per week with 200 workers. The rate of change of productions with respect to change in number of additional labor. So some number of additional labors have been increased. That number they will be telling us now is represent, that expression is given to be 300 minus 5x power 2 by 3. If 64 additional labors, so how many labors are increased now? 64 employed. Find out the additional number of units the company can produce. Let P be the additional product produced for the additional of x labor. So dP by dx is equal to 300 minus 5x power 2 by 3. So we are going to integrate this now. So P is equal to integral. Now the number of employees have been extended, have been increased is 64. So 0 to 64, 300 minus 5x power 2 by 3 dx. I am going to integrate this. So I will get it to be 300x minus 5x power, it is 2 by 3, no. So 2 by 3 plus 1 will become 3 LCM, here also 3, so 5 by 3. So 5 into this 5 by 3 goes to the numerator, so 5 gets cancelled. So we will get it to be 3x power 5 by 3 within the limit 0 to 64. So the upper limit is 64 and lower limit is 0. Now kindly, carefully handle this, because when you are substituting the upper limit, there are chances for you to make mistakes. So 300 into 64 minus 3 into x, in the place of x you will substitute as 64 the whole power 5 by 3 minus 300 into lower limit 0, here also it becomes 0. So 300 into 64 minus 3 into 64 power 5 by 3 is nothing but I can write it as 64 the whole power 1 by 3, means cube root of 64, that is 4 into 4 into 4 cube. So it will be 4 cube the whole power 1 by 3, 3 and 3 gets cancelled, so 4 power 5. So 4 power 5 is nothing but 1024. So when I am substituting, it is 19,200 minus 3 into 1024. So the answer is 16,128. So number of additional units produced is actually 16,128, but the total number of units produced by 264 will be, because initially it was how many total number of workers? 200 workers, and the production was 50,000. After that 64 workers were added, additional labors were added. So for 200 it is 50,000 and for 64 more it is 16,000. So adding together we are getting it to be 66,128. Now we will see the example 3.14. This is very important 5 marks sum. The rate of change of sales of a company after an advertisement campaign. So after advertisement campaign, the rate of change of the production is given to be f of t is equal to 3000 e power minus 0.3 t, where t represents the number of months after the advertisement. Find out the total cumulative sales, means the total cost they are asking, after 4 months and the sales during the 5th month. After finding out the total sales due to advertisement, okay, so we are getting it to be e power minus 1.2 is equal to 0.3012, and this one is for the 5th month, okay, that you can do it on your own. And here let me do the first part, that is assume that f of t is a total sales after t months. So sales rate is d by dt into capital F of t is equal to small f of t. So capital F of t is equal to integral 0 to t f of t dt. So the total cumulative sales after 4 months will be f of 4 is equal to integral 0 to 4 f of t dt. So this will be 0 to 4, 3000 e power minus 0.3 dt. So I can take this 3000 outside as a common thing, and here I will be having it as e power minus 0.3 dt. If it is e power x, when I integrate it I will get it as e power x by 1, since the coefficient of x is 1. If it is e power minus 6, I will get a minus 1 in the denominator. Similarly here also I will get a minus 0.3. So I can take the minus 0.3 outside, minus in the denominator will go to the numerator. I will multiply by 10 on numerator and the denominator. So what happens here? This 3000 becomes 30,000 and 3 will cancel the 30,000, will get it to be minus 10,000 e power minus 0.3 into 4 minus e power 0.3 into 0. This e power 0 becomes 1. So e power minus 1.2 minus 1. This e power minus 1.2 value they have already given in the question. See, I have written it here. So that I will just substitute it over here. So 0.3012 minus 1, I am getting it to be minus 0.6988 into minus 10,000, I am getting it to be 6,988 units. Okay, so this is what we have to do for the 5th month also. We have to just change the limit and do it. Okay, now there was another question, sales during the advertisement campaign. So during the advertisement campaign there is no particular months, so we will name it as 0 to infinity 3000 e power 0.3 t dt. So I can take the 3000 here also, so it is e power minus 0.3 t divided by again I'll get a minus 0.3. I can take the minus 0.3 outside, the minus will go to the numerator into 10 and by 10. So I'll get it to be 10,000, minus 10,000 again. And here e power infinity minus e power 0. E power infinity is nothing but 0. So 0 minus 1. So minus into minus 1 will become plus 1. So I am getting the answer to be 10,000 units. So this is how we have to do the sums, children. Children, we have seen few of the examples. Rest of the examples we will continue with the next class. Thank you, children.